All right, now we're going to work some more problems here, and our directions say to use rational exponents to simplify each radical. Okay, so in our first example here, we have the square root of 8, x to the 8th power. Okay, most of the time when we look at these, especially at first, we have a hard time dealing with this. Now, as we move further on and you work more and more and more problems, then you'll start to see sort of a shortcut. So I'm going to show you how that works right now, and then we're going to apply it to the next problem. Okay, because working with the square root of x to the 8th is a little bit daunting. I mean, we can't take the square root of x and then raise it to the 8th power, and it just gets a little confusing. So how about if we change this over to a fractional exponent, and then that will help us to be able to simplify. Okay, so looking at this problem, we would take our radicand, which is x, we're going to raise it to a power. Remember that the denominator is the index, so that would be a 2, and the power on x is 8, so this would be the same thing as saying x to the 8/2 power. Now, just like we did in the last video, as we move through these, we need to be, just reevaluating at every step and saying, okay, what can I do? What can I do? Well, I don't know what x to the 8/2 power is, but do you recognize that 8/2 could be simplified down? 8 divided by 2 is really a 4. So simplified, this would be x to the 4th power. Now, here's a sort of a shortcut way. Eventually, what we did was we rewrote this as a fractional exponent, but we could have done the same thing just by looking at the index here and saying, okay, how many times does 2 go into 8? Well, that would be 4 times, so our answer would be x to the 4th. That's sort of a shortcut way of looking at it also, just doing the division. Now, I also want to talk about an alternate way of looking at this also. Would this be the same thing as saying x to the 8th raised to the 1/2 power? It absolutely would, because the square root is the same thing as saying the 1/2 power. And then we could use another one of the exponent rules that says when we've got power to power, we multiply. So that would be x to the 8 times 1/2, which would be 8/2. Or we could have simplified first and said that was just simply x to the 4th. As long as you're using valid math rules, you may see things slightly different and approach it slightly different. And that's okay. You just have to keep in mind it must be a valid math rule. All right, let's look at this problem here. Here we have the cube root of 8a to the 3rd, b to the 12th. Now, we're going to take this one at a time. The cube root of 8 is something that we know, or we should know. That would be 2. Now, a to the 3rd, when we take the cube root of that, we could either come over to the side and rewrite that as a fractional exponent, so the power over the root, and 3 over 3 would be 1. Or we could look at it and say 3 goes into 3 one time, so that would just be a to the 1st, or just a. For the b's, we could do the same thing. We could either change it over to a fractional exponent. The power is 12, the root is 3, and 12 over 3 would reduce down to 4. Or we could just look at this and say 3 will go into 12 4 times. So that would be the same thing as saying 2a b to the 4th. Now, if you didn't see it that way, you might have seen it as 8a cubed b to the 12th, and then raised to the 1/3 power. And then we could have done the 1/3 power to each one of those and then simplified more. That would have gotten us the same thing also. 8 to the 1/3 would be the same thing as saying the cube roots. That would be 2. A to the 3rd to the 1/3, power to power you multiply. So 3 times 1/3 is 1. And again, power to power we would multiply, so that would be 12 over 3, which is b to the 4th. We get the same thing.